Alright, so today we're going to be doing another review of Algebra 1. We are going to review how to add, subtract, and multiply polynomials because we're going to need that eventually to be able to solve and find zeros. So just one learning goal related to the title. I can perform addition, subtraction, and multiplication of polynomials of various degrees. So in yesterday's lesson we talked about the degree of a polynomial. So we should be able to do all three of these operations with any degree that we're given. So the directions are, again, just what you did in Algebra 1. If you want to add the polynomials, just identify like terms, combine the like terms. The big thing that people forget is writing in standard form. So remember, that means highest exponent to lowest exponent. So whatever the highest power is, that term should come first, and then you should go down so that the least exponent is at the end. To subtract polynomials is exactly like adding, except you have to distribute the negative to all terms, not just the first term. Then you do the exact same thing as you did when you add. So distribute the negative, then identify, combine like terms, write your answer in standard form. Multiplying polynomials is different. Sometimes it might mean to distribute, depending on the type of multiplication. Sometimes you might FOIL, and sometimes you're going to have to double or triple distribute, and I'll show you some shortcuts for that. Some shortcuts for special products. These ones, some of them you should already know. The sum and difference pattern. So if the two things you're multiplying are the same, except one's a plus and one's a minus, you know that the inner and outer terms are going to cancel. So just square the first term, square the second term, and put a minus between them. Square of a binomial, you should also know this pattern. You could FOIL it out, but it's much quicker if you know this pattern, than that is to just square whatever the first term is. So in this case, we would have a squared. Then it's going to either be a plus or a minus, depending on what the sign is here. So if the sign was a plus here, it's going to be a plus here. Then it's 2 times whatever the first term was, so in this case a, times the second term, in this case b, and then the last symbol is always a plus, and then you're just going to square the second term. So the second term was b, so b squared. So that takes less time than FOILing it all out if you know that pattern. For the first time since we are out of our quadratic unit and we're looking at higher order polynomials, we're going to look at cubing things. Remember, to cube something means to multiply it by itself 3 times. Now, this is supposed to be a shortcut. I'm going to be honest, I'm going to put it here because for those of you who are good at memorizing, it will save you a little time. But if you're not good at memorizing and you mess this up when you're memorizing it, it's not going to turn out well. So for most people, I would suggest that when you have something cubed, that you square it first and then just do a double distribution. The pattern works just like the square of a binomial does. So if you look at the first term here, if I want to apply this rule, first term is a, so it's going to be a cubed, then plus, then it says 3 times the first term squared, so that'd be a squared, times the second term, which is b, plus 3 times the first term, which is a, times the second term squared, which is b squared, and then plus the second term cubed, so b cubed. So again, if you are a quick study with memorization, this is a time saver. I have found in the past that a lot of people don't memorize it correctly. And so if that's the case, if you're not a good memorizer, then you shouldn't really try to use this shortcut. You should just multiply it out the long way. All right, so let's look at our examples. So first here, we've got find the sum or difference. So I'm adding. I still had people on the last test with a plus or minus between trying to FOIL things out. This is addition. So all that means is identify and combine like terms. So here's an x cubed, here's an x cubed. Here's an x squared term, here's an x squared term. Here is a plane number, there is no other plane number. Here is a linear term, here's another linear term. So I've identified all my like terms. I'm going to combine them. Remember that our answer should be in standard form. So highest exponents first. So my x cubes would go first. 10 plus 5 is 15. So that's 15x cubed. Then my x squareds, negative 5 minus 1 is negative 6. So negative 6x squared. Then should come my plain x's. So negative 2 minus 2 is negative 4x. And then my plain numbers, it didn't have any like terms to combine with, so just bring down your added 9. And double check, of course, that you do indeed have it in standard form, because that's going to be important. So as we look at that, it goes from highest exponent to lowest exponent, so we are in good shape there. All right, B, this is subtraction. So that means I have to distribute the negative first. So I always write it kind of above, distribute the negative to all my terms. So minus a negative becomes a plus, so that's plus 12x cubed. And then this is going to be a plus x. And so then I'm going to just cross this out. So I'm not even looking at that anymore because I want to combine it with these terms. So I would like for you to finish the rest of this. Now that we've got it distributed, go ahead and identify and combine your like terms, write your answer in standard form, and then come back to see if you got it right. So my first term is an x to the fourth, so I look over here and I do have another x to the fourth term, so these are going to be like terms. Here's an x cubed term, and here's another x cubed term. Then here's x squared. Do not have any x squareds over here. Then this is a plain x. I don't have any other plain x's, so nothing to combine that with. And then this one, also a singleton, no like terms there. So now when I combine them, and remember this was a parenthesis, that's not a 19. I've had people say, oh, 19. That's 9x to the fourth. Minus 3x to the fourth gives me 6x to the fourth. Then negative 12x cubed plus 12x cubed is 0x cubed. So those actually cancel each other. So go on to the x squareds. There was no like term for this x squared, so just bring it down. Then my plain x's, that would be over here. No like term, so just bring it down. And then my plain numbers, again, that's a parenthesis, not a 1, so that's minus 8. So 6x to the fourth plus x squared plus x plus 8 should be your final answer there. All right, the rest of these are multiplication. So depending on what type of polynomials you're multiplying is going to determine your steps. Here in A, I've got a binomial times a trinomial. So you have two choices here. You can either double distribute, so meaning distribute this x cubed to all three here and then distribute the 2 to all three. What I usually do when I have greater than 2 terms on any of them is I use what's called the box method. And so I just write it. I'll show you here. In a nice little box. It kind of helps you organize your terms a little bit better. So I put my binomial here, so x cubed and 2. Then I'm going to put my trinomial over here, so 5x squared and then 3x. Make sure you take the sign with it if it's negative, so minus 1. And this is just a way to organize double distributing. It's the same idea. So now I'm going to multiply this row times this column. So here's why we had to review exponent rules, because that's going to be 5x to the fifth, because I add the exponents. Now this row times this column, so that's 3x x to the fourth. Again, you add the exponents, 3 plus the 1. Then x cubed times negative 1 is negative x cubed. So leave that. Then here, 2 times 5x squared is 10x squared. 2 times 3x is 6x. And 2 times negative 1 is negative 2. So the box is just to kind of better organize your terms and keep your signs. You do not have to do the box. If you just want to write all 6 terms out in a big long line, you can certainly do that. So now I just need to combine any like terms that I have and write my answer in standard form. So as I am looking at this, I have an x to the fifth. I have no other x to the fifths, x to the fourth, x to the third, x squared, x, and constant. I have no like terms. So there's nothing to combine here. So now I just need to write it highest exponent to lowest exponent. So 5x to the fifth plus 3x to the fourth minus x cubed plus 10x squared plus 6x minus 2. And that's going to be my final answer. B should be super simple. When you are squaring it, you've got your shortcut here. Again, shortcuts are meant to save you time. So if you don't know the shortcut, fine, then just FOIL it out. So if I'm using the shortcut, I'm going to square the first term. So there's the first term, square it, plus 2 times the first term times the second term, and then plus the second term squared. So exponent rules here, that's 25a squared. Then 2 times 5 times 2 gives me 20a, and then 2 squared is 4. Now again, if you are not good at memorizing shortcuts, then you should write this out. 5a plus 2 times 5a plus 2, and then FOIL it. So 25a squared plus 10a plus 10a plus 4. Notice that it gets you the same answer. So if you know the shortcut, use the shortcut. If you don't, FOIL it out. Either way, your answer should be 25a squared plus 20a plus 4. C is a cube. So again, if you want to use the shortcut, go right ahead. Most people here have trouble with the shortcut. So when I do it, I'm going to do it this way. I'm going to do 2m minus 3 squared times 2m minus 3. Because when you're cubing something, you're multiplying it by itself 3 times. Here's 2 of them. Here's the third. So I'm going to go ahead and square this out using the shortcut first. So squaring the first term would give me 4m squared. Then 2 times 2m times negative 3 gives me my lovely negative 12m. And then squaring negative 3 gives me a plus 9. Again, if you don't know the shortcut, I got this from basically foiling that squared term out. So now this problem looks exactly like what I had in A. I've got a binomial times a trinomial. So I showed you the box method in A. If you like that for organizing, then you can use that again. If you don't, you can always just double distribute. So distribute the 2m to all 3 terms, distribute the negative 3 to all terms. So I'm going to use my box here and write my trinomial terms along the top. And I'm going to write my binomial terms along the side, so 2m and negative 3. So now my box tells me how to line everything up. So 2 times 4 is 8, so that's 8m cubed. Then that gives me negative 24m squared. And then this gives me 18m. Now bottom row, negative 3 times the 4m is negative 12m squared. That's going to give me negative 3 times negative 12 is positive 36m. And then this gives me negative 27. So now I need to combine like terms. The first time I used the box, I didn't have any like terms to combine. So here I do. I've got, here's a squared term, here's a squared term, here's a linear term, here's a linear term. So highest exponent is the cubed, so 8m cubed. Then these two combined is going to be minus 36m squared. 36 plus 18 is 54, so that's plus 54m, and then my minus 27. So there is my final answer. Here in D, this one should be review. This is a sum and difference pattern. So foiling, but the outsides and insides are going to drop out. So you go ahead and try this one. You should know how to do this, and then come back and check it. So because this is a sum and difference pattern, we know from up here and from Algebra 1 that the inner and outer terms are going to cancel. So you don't have to write the inners and outers. Now, if you're a person who's going to forget it on another problem, if you don't write it, that's fine, but you don't need them. So first terms, 3x squared times 3x squared is 9x to the fourth. Then my last terms, negative 2 times negative 2, or positive 2 rather, is negative 4. So I've got 9x to the fourth minus 4. No like terms to combine, so that is it. E, my last problem. I've got 3 things to multiply together. There's no way to multiply all 3 things together at once. So what you need to do is pick 2 of them, FOIL it, combine like terms, and then do a binomial times a trinomial. So I would just start here. It doesn't matter what order, but I would start by multiplying these together, then take the answer from that and multiply it times the x plus 3. So we've kind of already done that up in C, multiplied 2 things together to get this, and then multiplied it times the third binomial. So again, I'd like for you to try this one and then come back and check it, because you have to practice it yourself. So when I multiply these first 2 together, if I'm foiling, my firsts, x times x is x squared. Outside terms, x times negative 1 is negative x. Insides, negative 2 times x is negative 2x. And last, negative 2 times negative 1 is positive 2. So that's what I get when I FOIL those first 2 together. Now, do not forget to combine these like terms in the middle before you do the box or double distributing. Otherwise, you're making so much more work for yourself. So combine like terms first. That gives me minus 3x plus 2. So now I can take this and do my box or my double distribution. So since I haven't shown a double distribution yet, I'll show you that. And it really is the same thing. It's just that it's just organized linearly instead of in the boxes. So what I'm going to do is going to distribute the x to all 3 terms first. So x times x squared is x cubed. X times negative 3x is negative 3x squared. X times 2 is 2x. Then I'm going to do the same thing with the 3. So 3 times x squared is 3x squared. 3 times negative 3x is negative 9x. 3 times 2 is 6. So now I just need to combine like terms. So here's 2 different squared terms. Here's 2 linear terms that are like. So when I combine them, of course my x third didn't have anything to combine with. Negative 3x squared plus 3x squared, those cancel. So no x squared terms left. 2x minus 9x is negative 7x. And then my plus 6 needs to be brought down. It did not have a like term to combine with. So hopefully you got those right. Again, for the most part, the concept is just a review from Algebra 1. Just do not forget that you have to FOIL whenever you do those binomials times binomials. And do not forget also, when you are subtracting, distribute that negative first and then combine your like terms. That is it for today.